right, everybody. The warm-up today is based on the notes we did on Thursday. I keep saying yesterday and I keep saying Friday, which are both false. It was Thursday. So if you weren't here, hopefully it'll make some sense when I go over this. This is literally just a problem from your assignment today that I changed the numbers on. So you really want to make sure you understand this, okay? This is like example 1 or 2 that we did go over on the notes. So today we're going to do examples 3 through 6, and we'll be done with the notes from Thursday. And then I'll give you the 9.3 assignment, and you'll have today and tomorrow to finish that. But let's look at this. Let's read it. The cost of tuition at UTSA is $14,500. Not necessarily true, just a number I made up. Okay. For in-state students, this cost represents a 3.5% increase over last year. Assuming that tuition rates rise at the same rate, how much will it cost to attend in 3 years? Okay. Now, on your notes, there's like a bunch of different equations. Okay, if you're looking at this yesterday, there's like all these different equations you can use, right? But we only talked about these 2. So there's increasing or appreciation or inflation, and then there's decreasing or depreciating. Okay, so you tell me, after reading this, what's the key word that's going to help us determine which one of these it is? Increase. Y'all see it right here? After the 3.5%. Increase means you're going to use the increasing. Now, by the way, the only difference is there's a plus sign and a minus sign, so hopefully it's kind of obvious. Hopefully. But nonetheless, let's go ahead and figure this stuff out. What is my initial value? Let's read it. The cost of tuition at UTSA is what? $14,500, right? Okay, so that's my initial value, $14,500 plus your root. Now my rate is in percent, and the only percentage I have here is how much the cost represents, a 3.5% increase. So my rate is going to be 3.5%. Now, if you were awake and listening, yes, almost said yesterday, on Thursday, okay, you would know that we have to turn this percentage into a decimal. What's the rule for turning a percentage into the decimal? Which way does this decimal go, left or right? Right is wrong, left is right, which is weird, right? It's going to go 2 to the left. So watch this. You get rid of the percentage sign, and you go 1, 2. Now, if you go over 2 and there's a space here, put a 0 there, right? So this is really 0.035, otherwise known as 0.035. Does everyone see how to turn a percentage into a decimal? You've got to know that you move the decimal 2 to the left, okay? You should not be on a phone. That's a lie. Put it away. Thank you. Now, the equation we're going to use is this first one, P 1 plus R to the power of T. Okay? So I know my P is my initial. By the way, the reason initial is not I, the reason why it's P is for the word principal, and principal is more than a person at school. Okay? Principal is the initial amount. Okay? So like if you buy a house, the principal is literally how much it costs. Okay? Literally. All right. So we have the P, we have the R, we need the T. What's the T in this situation? How many years? 3 years, yes? So let's go ahead and plug P, R, and T into this equation. So Y equals P, 14,500, parentheses 1 plus R, which is 0.035, to the power of T, which is 3. P, 1 plus R to the T. Please be careful in the future if you see one that says depreciating or decreasing, you would put a minus sign in the middle. Okay, but this one's plus. Okay, could you plug that in the calculator? Okay, I did. Do y'all see it right here? You do 14,500, parentheses 1 plus 0.035, parentheses, caret 3. Okay, where do we get the 1 from? So the original equation right here has a 1. If you're increasing or decreasing using this formula, yes. Now, if it's continuously, then that's the one that's the third row, PERT. If it's a continuous growth, that's when you're going to use that one. I'm going to show you the examples so you'll see that, okay? But for this one, yeah, there's a 1. Okay, so I plugged it in, and what did I get? I got 16,076.40. Okay, that's a good warm-up. Now, everyone needs your 9.3 notes out from Friday. Sorry, from Thursday. Who was not here Thursday? Or who lost it? Please come grab it from here. Raise your hand. Who is it? 1, 2, 3, 4, 5. If you were here Thursday, you got this for sure. So, okay. Maybe 7. Close. Close. Yes. You're gonna miss the most important notes of your life. Wow. Finished? No, we only did example 1 and 2. Okay. You should get a binder. I do. Ben? Okay, so let's go ahead. Get a bigger backpack. Nah. I'll get you a free one. Okay. Then you, sounds like you're refusing. That's bad form. All right, everyone's done these 2 examples. While we're waiting for some copies, if you didn't get this on Friday, write this down real quick. Sorry, Thursday. Oh, okay. If you didn't get the Thursday, write it down like super fast on the back. Example 1 and 2. Yeah, example 1 and 2. 9.3. What you get? Who else needs the notes? Who else needs notes? I didn't do that. I just forgot. Who needs notes? Got it? All right. Let's go to example 3. If you need a picture, take a picture of that real quick or get it off the Google Classroom later. We are moving on to example 3 now. Ready? Here we go. My bad. That was the final yellow answer for example 2, $1.20. $1.20. All right, example 3, here we go. Now, these are the formulas we're going to be able to use. So let's look at example 3. It says, a biologist is studying a newly discovered species of bacteria. He places, by the way, this is a population. Usually you think of people, but bacteria is still a population. Okay? He places 100 bacteria in a petri dish in order to study its behavior. The bacteria is estimated to be growing at a rate of 17% per hour. How much bacteria will there be in 12 hours? Does everyone see the word growing? Okay, this is a population that is growing. So let's go back to these formulas. Which one of these looks like a population that's growing equation? Population increasing. Y'all see that? This is called interest compounded continuously. Okay. Y'all notice that whether it's humans or bacteria or whatever, you don't just get like a new set of humans every year. You know, it's continuously, people are coming and going, being born, peacing out, all that good stuff. So this is continuous. P times e to the RT power. Cool? So back to example 3. What is my P? What's my initial value? How many bacteria do I start with? 100. Write it down. What's my rate in percentage? What's my rate in percentage? 17%. Now, can you turn that into a decimal for me? 2 to the left makes it 0.17. Is everyone familiar with how to turn a percentage into a decimal? We've done it a few times on Thursday and today. Okay, now remember your formula is P times E to the power of RT. Okay, so the only thing we need now is my T. What's my T time here? 12 hours. Okay, so I'll put a little T there. So let's plug it in with our P, our R, and our T, right? Please remember, E is not a variable, E is actually a number, okay? So let's type this in. It's going to be P, which is 100, times E to the power of R, which is 0.17, times T, which we're going to eventually plug in as 12. So again, T is 12. Now real quick, if you plug this into your calculator, y'all know where the E to the power button is. So look under your calculator. Hey, look at your calculator. Right under the caret, y'all see the EX. You're either looking at me or looking at your calculator. Everyone see what E and the X is. That's the only way you're going to be able to type this into the calculator. So again, you see what that is? Yeah. So when you plug it in, it's going to look just like this. 100 times e to the power of 0.17 times 12, and you end up getting 769.061. The 1, we can round that 6 down to just 6, okay? They rounded to the nearest bacteria. By the way, there's no such thing as decimal bacteria. You're either one whole bacteria or you're not, right? Just like you all are all one whole person or not, okay? Even if you lost a toe or something, you'd still be a whole person. Okay, so 769 is our answer. Does everyone see that this was a growing population? That's why we used a different formula. Now, example 4 is a little different. In 1975, a certain type of insect found only in the Amazon rainforest had a population of $750,000. I'm going to remember that population word. The population has been what? What? Decreasing. Okay? Going down at an average rate of 2.5% annually. How many insects will there be in 2050? Now, everybody, just like the last one, we're talking about a population of insects this time. So let me go back to our formulas. If you're writing this down, perfect. Does everyone see that we are doing the population again, but on the right side it's population decreasing. P times E to the power of negative RT. It's a negative rate because it's decreasing. Very good. So let's figure out what's my P. What's my initial value, student? 750,000. So let's write that down for my initial value. What's my rate, y'all? 2.5%. Can you turn that into a decimal for me? By the way, 2.5% is wrong. By the way, if it says decreasing, you got to throw what in front of that 2? Negative. This is so important. They will not give you the negative sign. You've got another word. Decreasing means it's a negative, right? What are you doing? Okay, so again, negative 2.5%. If I convert it and I move it 2 to the left, what do I get? Yes, it still remains negative. Negative 0.025. When you move the decimal 2 to the left, if you have an empty space, you got to put a 0 there. Negative 0.025%. All right. Now, we're going to plug it into this equation. Y equals PE to the negative RT. Here we go. 750,000 times E to the power of negative 0.025 T. What's my T? T is time. Now look, they asked us in 2050, but what year did it start? 75. So from 1975 to 2050, how many years is that? More than 70. 75 years. Y'all, I hope y'all can subtract 20. I mean, in your calculator, 2050 minus 1975. It'll give you the amount of years. Find the difference. So it is 75 years. So T is equal to 75. That's good. So if you plug that in to your calculator, you end up getting 750,000 times E to the power of negative 0.025 times 75. You get 115 and 16 insects left in 75 years. Okay? And those are the hardest problems you'll ever see. You'll never understand it unless you were here for the notes. Oh, dang, you just got here. Dang. Sheesh. Sheesh. 75. All right. 75 years. All right, now, has everybody gotten example 3 and 4 down? If you wanted the mushrooms. All right, you have to get over it. Master Chief? Master Chief? Master Chief? Master Chief? All right, example 5. Everybody, all right, example 5. Now, let's look for keywords. Example 5 says 80 grams of cobalt-58 have a what? Half-life. Half-life. Let's go back in time here. Is there something on here that says half-life?
Oh, no, that one looks bad.
All right. Half-life is P times a half to the power of T divided by K.
Oh, I get it. Half-life.
That's why there's a half there, yeah? Okay, so what's my initial value? What's my P? How much P do we have? 80 grams of P, all right? Cobalt-58 is just the name of the element or whatever it is. Yeah. What's the factor? So how much, what's the amount that it's changing each time. What kind of life does it have? Half-life means half rate, half factor, sorry.
So is that half the 71?
No, just like legit, the factor is a half. How do you write a half as a decimal? 0.5. Now, when we're looking for the period, we are looking for how long it takes for it to go half. So how many days does it take for it to be half?
71.
71. If it says it has a half-life of 71 days, the 71 days is the period. And the period is signified with the letter K for some reason. Okay? Very important. The amount of time it takes to change is the period, but the T time is what they ask you at the very end. How many grams are going to be after 213 days? That's your T. Okay? Please notice there are two different day values. How much time it takes to change is your period. The amount of time they're asking you for is your T time. Okay, so what do I put for period? Oh, yes. Yes. I don't know.
Okay.
I'm not a sign languager. All I know is
that 3?
no balls. Now, period is 71 days. Write this down. I don't know. I wouldn't guess. All right. So y equals, and remember, our equation for half-life is p times 1/2 to the power of t over k. All right, so write my equation. The p-value is 80. The 1/2 goes in the parentheses. T is on top, and then k on the bottom is 71. Can you plug in 213 in for t? 80 times 1/2 to the power of 213 over 71. You end up getting straight up 10. 10 grams of cobalt 58 will be there after 213 days if it has a half-life of 71 days, starting with 80 grams. Cool. All right, so this last one, the mold population, what? What? Triples, okay? So instead of it being a half-life, it's a triple life, okay? So instead of putting a half in the parentheses, you're gonna put a triple means times 3, right? Every 90 minutes, yeah, it's mold grows, right? So this is my rate. This is my period. What's my P? How many mold spores do I start with? Start off with 15. And then my time that I'm looking for is after 6 hours. So one thing I gotta notice, my period is 90 minutes, but my time is 6 hours. Does everyone know minutes and hours are not the exact same? Can I turn the 6 hours into minutes? How do I turn 6 hours into minutes? Nope. Nope. If each hour is 60 minutes and there's 6 hours, what do I do? No, not divide. Yes, there's 60 minutes, 6 times. 60 times 6. What's 60 times 6? 360. No scope. All right, 360 minutes. Now, don't hate. Now, this is my new T, 360 no scope. Let's plug in. What's my initial value? What's my P? What's my P? All right, put 15 here. What's my factor? How much is it changing each 90 minutes? Keyword, no, not 6. What is happening each 90 minutes? What's happening every 90 minutes? Okay, triples, which means times 3. Okay, the factor is 3. Period. What happens? The tripling happens how often? So my period is 90 minutes. So my equation is going to look like this. Instead of a half in the parentheses, it's 3 because that's my new factor. Okay? You'll do great. So 15 times 3 to the power of t over 90. T is 360. So you plug in that. 15 times 3 to the 360 over 90, and you get 1215. And that'll do. Bada bing, bada boom. As you're finishing writing this down, I'm going to pass out the 9.3 assignment you have today and tomorrow to knock this out. It is two-sided. Backside has a review on it, so it should be kind of easy on the back, hopefully. Now, if you missed part of the notes from Thursday, it's on the Google Classroom already. You can check it out. All right, let's work on that 9.3.